Hi everyone, my name is Vlad Shtibin. I'm an engineering manager here at SmartThings. We work primarily on rules, behaviors, so we'll talk a little bit about what you see in the app and where our team makes an impact. Does everybody here know what SmartThings is? Have you guys ever used it before? Show of hands. All right, cool. And have you guys used our APIs before? No, not. What was that? Yeah. So I'll go into SmartThings in a minute here. You won't miss out on that part. So talking about a little bit who I am and who our team is. It's kind of cool team. It's pretty unique. It's Samsung. We're a global team and we span across 3 different organizations. I'm in Minneapolis with 3 engineers there. We have QA out in Mountain View at the SRA office. We have a remote worker named Adrian who's going to be doing a session later who works on WebCore. Then we have our team in Suwon at Digital City, the mobile HQ. And then we have engineers at SRIB as well who help us on the WebCore project. So what our responsibilities are, we use custom automations, scenes, local smart lighting, and SHM in the actual app. And then we have other various features in the app as well. So if you go into like a device, you can set up an automation on there, like in 15 minutes, turn on a device. Or if you say, Bixby, in 15 minutes, turn off this device, that's actually Bixby calling our API to set up schedules. And then going forward, we are working on the public rules API, which is what this talk is about. So we're going to talk a little bit about SmartThings primitives, what is SmartThings, then automation, and then going into the intro to the rules API, and then we'll go into the actual grammar of the rules themselves, and then we'll show some example rules as well. So what is SmartThings and what can you do with it? So SmartThings is the IoT backbone for Samsung. All of your Samsung digital appliances, whether they're OCF or SHP, talk to our cloud. So we handle device events, we have device onboarding, et cetera, and it's not just Samsung and SmartThings devices. We handle a variety of protocols such as Zigbee, Z-Wave, LAN, and there's various ways that you can connect them to our platform. So if you're looking for IoT or getting into IoT, making a device and you want to have access to a huge ecosystem of devices and users that are using the devices and a nice app to play with, that's SmartThings. So at the end of the day, we're a cloud, API, and an app. So from a user perspective, what that means is why would they actually want SmartThings? Say that when you wake up, you want to turn on your thermostat because you're too cold in the morning. That's what I use my Ecobee for on SmartThings. When I leave home, I always forget to close my garage door and lock my door, so I automatically close my garage door and lock my door with my Yale lock and my linear Z-Wave garage door opener. While I'm away, I have monitoring set up in my house through Smart Home Monitor. That's our security solution, so I can get a notification if there's motion in my house. And we have a SmartThings cam that does object detection, so it's not just any motion. It can see if there's a person in my house. It'll let me know instead of just my dog. And then when I go to sleep, I always forget to turn off all my lights, so I have automations that turn off all my lights for me. Now, from a developer's perspective, there's a few entry points for us. One, if you're manufacturing devices or you want to have connected devices, we have APIs for connecting devices. Cloud-to-cloud integrations are very popular ones. So we have API endpoints with a schema, very similar to what we have with Amazon Alexa. You can just call into our APIs and send us device events, and that'll be available for anybody on the platform. And that's really useful for rules, right? If you want to create a rule condition, it says when something happens, you can send us the device events, and anybody can plug into that. And then automations, because that's the really fun part about this IoT stuff. It's you have a mobile phone. You can turn off your light if you want. That's kind of boring. But I don't actually want to do any of that. I want to walk around my house, and everything happens for me. Or for my wife, if she wants to speak to Alexa and it does something, that's the fun part of the platform, and that's where we're focused at, and that's what we're going to be talking about today. And then the SmartThings app, if you want to have your device have some dashboarding or some extra information in it, we have APIs that you can basically show the user what you want by going into the SmartThings app. This app is installed on most Samsung phones, so you have really good penetration for your devices because it'll just be available for the users. Developing this stuff, we have a few ways of doing it. One is the IDE, and this is the way that we've had development for the platform for a very long time. This is a Groovy platform. You can write Groovy DTHs and smart apps, and I'll show you what that looks like in a little bit. And then the latest offering we have is like the Samsung Developer Workspace. And that's where all of our stuff is. That's where the Rule API is, and all of our docs are there. And that's an HTTP-based API, as opposed to the old one, which is all Groovy-based. And yeah. So before we go in too far into rules, you kind of need to understand our data model. For SmartThings, we have a SmartThings user. That'll be the person that's actually using the app or the phone. And they have a location. So my house is a location in SmartThings. So when I onboard onto the app, the first thing that I'm going to do is I'm going to create a location. Then you onboard devices onto that location. So all of our APIs are very based on doing something in a location with a device or with something about that location, like turning on the security state of that location or changing the mode, like if you're home or away. For the device side of things, the big things that you need to know is that you have a device, and a device has components and capabilities. A device like a light bulb or a switch or a contact sensor, those are very simple devices. They'll usually have like a single component, and that's always called main in our API. Now, as opposed to like a refrigerator, you might have a smart refrigerator with multiple doors that all have temperature readings on them, and they'll have multiple components. So you can dig into a specific device and its various components. And then the other part, the real interesting part, is the capabilities. The capability is is the description of what a device can do. So we have a capability like a switch that can be on or off, or a switch level that could be the dim state of the device. If you have a dimmer and you dim it down to 50%. Or a contact sensor if you open and close. So you define what type of device you have, what components it has, and what it can do. So there's a very simple capability. This is probably the hello world example of capabilities, is the switch capability. And it has an on and an off command. So capabilities are defined by their commands and attributes. Commands are what you can do to a device. So once you onboard your device onto our API, you can send an API call to us saying, send the on command to this device, or send the off command to this device. And this is all defined in the capability. And then the attributes are the types of events that a device can generate. So when a switch actually turns on or off, an on or off event is generated. So the same thing with like a TV. So if you have a Samsung TV and you hit like the plus or minus button on the remote, those events are going into our SmartThings cloud, and then you can create automations on them, and yeah. So there's different types of automations. As I said before, we have the IDE, and now we have the developer workspace. We have Groovy Automations, SmartThings API, and then the Rules API. So I'll show you quick what the different ways that you can build automations on our platform are. So yeah, first thing I'll show you is the SmartThings IDE. This is kind of our legacy system and how we've interacted with the platform for a long time. So you can log into our IDE. It's graph.api.smartthings.com, and then go to My Smart Apps. So there's a few smart apps installed here already. The WebCore one is part of a different talk, but let's go to like a very simple automation here called Big Turn On. So this is what automations used to look like on our platform. This is all Groovy. You define the name for the automation and description for it, and you have a preferences section. So the preferences section, when the user goes into the app, it's the input for it. So what this automation is doing is on installation, it's subscribing to this is not the right one. Let's do a new one. So let's turn it on when it opens right there. So yeah, so in this case, we have two inputs. One is when the door opens, the user will see that, and they select a contact sensor. You give it what capability of the input device you want, and then it turns on a light. So you give it the capability switch. So you select which switch you want to turn on. And then when the user hits save, the installed portion of this code runs, and we say subscribe to contact open events for this contact sensor, and then run the contact open handler function when that event happens. And that contact open handler function is defined right there. So what we're doing is we're doing a couple of log statements, and we say turn on the switches. So this is the Groovy way of doing automations on the SmartThings platform. There's some benefits to it, and then there's some cons to it, right? So for the benefits, it's really easy to get started. We have good documentation around it. That chunk of code to actually make things happen in the physical world is pretty small. The hard part is that it's hard to distribute. We don't have a good catalog for distributing these apps. So what you'll commonly see on our community forums is very popular smart apps being shared amongst users, and you have to copy-paste code into your own account. And there's not much developer visibility. You don't really get to see what's actually happening on our platform, because once you save this Groovy app, it runs on our cloud. So you can't see if it's broken apart from like log messages. If there's a cloud issue, it's really hard to debug, especially if you're a developer and you have users complaining. You generally have to come to us to figure out, oh, what's actually happening behind the scenes. Now, the second way of doing this is the new SmartThings API. It's a higher barrier of entry. Personally, I think it's an HTTP-based API, which means that you have to manage your own runtime and run your own code. So you might put up a web service with an HTTP endpoint, register your app, and the SmartThings platform will call into your app whenever there's an event that you're subscribed to. Or your app can call into the SmartThings API whenever you want to send a command to a device or change like a location state. So yeah, maintaining your own code, maintaining your own runtime, and there's a catalog for distribution, so you can get your app published, and then it'll show up in the SmartThings app for other users to use. Now, the Rules API is kind of a mix between the two. So the Rules API still runs on the SmartThings cloud, but we're managing the runtime now. So the rules are actually described in JSON, as opposed to you having to stand up a web service and having to write out code that describes what your automation is. All you have to do is send us a JSON blob, and we'll run it. So before we go in too far, I'll just show you what like one of these looks like. So let's go here first and take a look at the actual API. So going to the SmartThings API here, whereas in the contact sensor, or in the Groovy case, we wrote Groovy code to create a subscription. In the API case, we have to make an API call to create a subscription, and then we'll get called back. And then if you want to send a device to a command, you would execute commands on a device by making an API call to this device. So those are the two previous ways of dealing with automations. And now this is what a rule looks like. So let's take this apart a little bit. So as opposed to having Groovy and having to write your own app to do automations, what we have here is a JSON object that describes an automation. So we're saying we have a name. If a contact sensor opens, then update switch B. So we have an if block, an equals block, and then a right and a left for the equals. So what we're saying is when that contact sensor is open, then is the next piece of it here, execute a device command on this switch. So if I save this rule, let's see, this guy. So when I save this rule, I have this contact sensor up here. Hopefully the network's working. There we go. So I had some string interpolation here. So this actually got replaced. You saw the contact sensor brackets. This is the device ID of that contact sensor, this contact sensor. And then SDC Samsung is basically these 7 nanoleaf control modules that got the on command sent to them. So how do we actually get to this stuff? So let's go over here. Yeah, so to actually do that, we need to take a couple of steps. First, we need to be able to authenticate to the platform. What I did was I generated a PAT token, and I'll show you how to do that quick, and I provided some permissions on that token. The other option you have is going through an OAuth flow. I'm not going to go through the actual flow of OAuth, but I'll show you an actual implementation of that as part of the web core talk. So going back to this, in our developer documentation, we have like an authorization page. And if you go into this authorization page, we have this personal access tokens area. So you can open this up. And this is our personal access token page. You have to be signed in with Samsung account to actually access it. And once you do that, you have access to the devices on your account. And this isn't something that you would use to like distribute your app. This token is only valid for your user. So it's a very good way to test our API if you want to. You hit generate new token. You give it some name, SDC session token, something like that. And then, if I can spell, then you select what scopes you want for your token. So in this case, I'll say I want to be able to list all devices, see all of them, manage all of them, update, delete them, and control them. I'll say I want to be able to see all of my locations, and then I want to be able to do everything with rules. So manage all rules, see all of the rules, and control the rules. And I hit generate, get the token, and then you just plug it right into Postman in the authorization header. So in this case, I have my user token defined. You just do bearer and then that token. So the next thing we need to do is figure out what location we're running these rules in. And let me turn this guy off so you guys aren't blinded. So in this case, I'm calling the SmartThings API. All of our URLs are api@smartthings.com. In this case, I'm calling /locations. So this user account that I'm using is just specific for this SDC session, and I get back a location ID. So that's the second piece I need to create this rule. Because the URL is right here, and we need to provide a location ID because a rule is installed in a location ID. Then the next thing I need to do is I need to get devices for my rule. So on this account, I'm making a call with that same PAT token to the /devices API. And I can see all of these device IDs, the different types of devices I have. Let's see if I can scroll down here. Yeah, so this is a better view. OK, so this, for example, this G right here on this board has a device ID of 07B. It's this UUID for it. And it's got a single component. Like I said, every device has to have components. And this component has a list of capabilities. So what we can do with this device is use the switch capability to turn it on or off, use switch level to change the dimmer state, or use color control to change what color it is. And then color temperature can be controlled as well. So going back to here, let's go to the capabilities reference just so you can take a look at some actual capabilities and how they're defined. And so this is all on smartthings.developer.samsung.com. So here's the acceleration capability, for example. This capability doesn't have any commands attached to it, but it has an acceleration attribute. So you could create a rule that subscribes to the acceleration of a device. So this contact sensor, for example, has an accelerometer in it, so you can subscribe to that. So what you're doing is you're getting your locations, you're getting which devices, you look to see which capabilities they have, and then you can use our capabilities reference, and we have a capabilities API if you want to do it programmatically, to see what you can actually do with that device. So once we have that, then we can just plug these guys right into our rule JSON, and you'll be constructing rules. So that's basically how you deal with our API. The PAT token is one way of authenticating against it. The other way is through an OAuth inflow. That's documented on our site. So let me close these guys up, and then go here and go here. So WebCore is an app that is a very popular SmartThings Groovy app. So I just went to stc.webcore.com, and we rewrote part of the app to run on our rules API. So the first thing you have to do when you actually want to use this app is sign into Samsung account. And this is the OAuth flow that I was talking about. So I'll go to vlad@smartthings.com and put in my password. And then we go to an authorization page. It asks me what location I want to access, and then what scopes that I want this OAuth client to be able to have access to. So in this case, the available scopes for this app are reading all devices. WebCore is a rule builder, so you need to be able to figure out what devices you want to deal with. Read all locations. You need to know where you're installing this rule, and to be able to read, write, and execute rules, because you want your list of rules. We don't really need execute in here because you can't manually execute a rule through WebCore, but read and write are important. So it goes through this OAuth flow, and there's a Node app sitting behind it. And now it has a token that can be used to call the SmartThings API. And now you can configure stuff in WebCore. So I'll just show you quick. I won't go through all the way of creating a piston, but I'll just show you that it has like access to our devices now. And then it gets the device IDs, creates the rule, and then moves on. So yeah, this is basically what we just walked through. It's pretty simple. Get a PAT token, find the ID that you're interested in, and then find devices and create a rule. Okay, so what is the rule API? So what we end up having is a new DSL. We have a grammar documented for this actual rules. So we have defined conditions, actions, and operands that you can use within it. So you'll really need to understand the rule grammar to be able to create the JSON that's being used. It's a hybrid approach of the endpoint app world and the Groovy world, because you don't need to stand up your own service, and you don't need to, and you can still have your own configuration page handled by your side of things. So the only thing that you no longer need is the execution lifecycle. So you don't need to stand something up to handle the events, but you do need something to handle configuration for it. Okay, so what do we want to accomplish for this? One thing is we wanted to share our work. We saw that WebCore was very popular. A lot of people are interested in rule builders. There's a partner of ours named Sharp Tools that also has a rule builder that's integrating with us. And our users really care about being able to create rich and complex automations. And we've had a lot of experience with this working through our app. We constantly get feature requests through various parts of Samsung of adding new features for automation. So we thought we'd like to open up a public API that others could use from what we've learned. Reduce expenditures and operating costs is another huge part of this. The Groovy world is very expensive to be running Groovy apps. It is not necessarily scalable yeah, it's not a scalable approach to automating everybody's house. The rule API, on the other hand, just is a simple JSON parser and evaluation engine. It costs a lot less than what we're using today for Groovy. It's easy to use. You no longer need to know how to write Groovy. You don't need to know how to stand up your own web server. You can just build a simple JavaScript app to build JSON. And then the last part of it is targeting local execution. So for those of you that don't have your house automated, local execution is a really important part of IoT. There's latency in the cloud. Sometimes the network goes down, as we've all seen here today and yesterday. So we really want to be able to do things on the LAN. So the way that we've built this rule API, it's been designed to support local execution from the ground up. So this API is written in Rust, and there's a central rule evaluation engine in it. And then the interfaces to actually talking to our APIs are two separate packages. So we have a hub-based interface, and then we have an API-based interface. So yeah, we are planning on releasing local execution sometime soon. So be on the lookout for a firmware update that adds that. So it's a really good option for those that want fast, secure, and stable IoT automations. So we went through looking at creating a really simple rule. Here's the API for the rule API. So we have a URL pattern called behaviors, and behaviors is the name of the actual rule engine. So while these are rules, at the end of the day, what you're actually executing is behaviors. So that's the grammar we use for this. And you can get, put, post, and delete a rule. So yeah, here's the same information. And then you can also execute a rule manually. So in the case of the first rule that we looked at, if a contact sensor opens, then update switch B. What we had was some conditions that triggered this rule. So if contact open, then do something. But you can also manually execute rules. So in this case, I'll say, let's do this in a different color for fun. So in this case, I have a rule that is going to turn this Samsung sign green. And let's take a look at this. This Samsung, SCC Samsung variable is just a list of the device IDs. So it has one action in it. It has one command in it. We select which devices we want and which component on those devices, which capability, and which command we're sending, and then the arguments to that command. So I can just save this rule. I get back the ID for the rule. And then in the URL, I can just add in execute, and then should execute. Now we have a green sign. Okay, so we can go pretty deep into the grammar. So we have documentation, and everything's defined in YAML. So let me actually, this isn't as good of a view as this following one is. Let's go to S. Here. Okay, so SmartThings API. So yeah, so there's documentation around rules, but the full actual grammar is going to be, let's go here, our CPI docs. So this will get published shortly after SDC. So this is what you'll actually see when you're creating rules. So create a behavior. A behavior at the top level has names, a name, actions, and then a sequence if you want to execute it in serial or parallel. So say that you want to turn one light on, then the next one, then the next one, or do it all at the same time, which is what I did. That's what handles that. So your array of actions, that's the top level object that describes like what a rule can do. And we have different kinds of actions. So an if action is what I showed earlier, this guy right here. Let's scroll this down. So you can have an if, a then, and an else. So that's basically what defines an if action. And the if part here is a condition, and the list of conditions that are available is right here. There's a huge amount of them, so basically you can have an equals condition, which is what we use here, and that has a left and a right field, and that is an operand, and an operand is the thing that you want to reference in your rule. And in this, so that's an equals condition. Greater than has left and right as well, less than or equals to. So if you want to have a rule fire when a dimmer goes above like 50%, then you would use a greater than condition. So it's pretty simple to understand. Or if you want to do something when the temperature falls in between these two values, you'd use a between condition. So these are single operand conditions right here. But if you want to do something that's more complex, like do ors and ands and verify multiple conditions at the same time, you could use the and or the or field here. And just takes a list of conditions. So these are recursive, right? So you can have a condition within a condition, and you can have them grouped up with these ands and ors. And on that subject, so the case of like a contact sensor opening and then us turning on the light, okay, that's pretty cool, but you could do it right now in the SmartThings app using our current rule API. And users generally want some higher degrees of complexity than just that. Generally, users, like when I walk in my house and my rule said, if there's motion, turn on a light, and it was in the middle of the day, that's kind of annoying. I wouldn't really want that. So what the rule API lets us do is, so here we have if there's contact, then do something, but then in the then block, we're evaluating another if condition. So these things are recursive. So in this case, what this rule is doing is it's saying, if my contact sensor opens, so say that you're opening like a kitchen cabinet, then check to see if my kitchen light is on, and if my kitchen light's already on, then I want light in my cabinet. So at that point, turn on the cabinet light. But if my kitchen light isn't on, well, then I probably don't need light. So then don't turn it on. So this rule that can be conditionally based on various scenarios. So that's where the complexity comes into this. And you can make some very cool scenarios with this rule API because of that complexity. And what will happen is these conditions will basically get evaluated every time there's an event. So in this case, the open event will come into the platform. So yeah, if we walk through this. So say I have my contact sensor and the open event comes in. The first thing we do is we evaluate this equals condition. Then we go into the if block and we see another equals condition. And we check the state of the other device. And since that fails, I have this then block here. Then won't get executed because this will evaluate to false. Only the else block will get executed. In else, I don't have anything there. But then say that my my light was on, the same thing will happen. Contact would open. Light would, we'd go in here. We'd evaluate the level of the switch of the light. And then we'd execute the other command on the device. So yeah, we kind of looked at the documentation. There was a little bit more of the API. There's a lot of stuff that's in flight that's being built, but this is what's available in production today. So if you go into that PAT page and you have a Samsung account, you can create a rule scope token, and you can create rules with this stuff in it. So you can do that if action. You can do a sleep action. A sleep action will basically say, if you want to turn on a light, and then wait 15 seconds, and then turn off a light, you'd use a sleep action for that. Command action is for sending device commands. Every action, there's 2 flavors of that. If you want to build a cron, so say every 15 seconds do something, you would use an every action. So in this case, I have this every 15 seconds rule. So the list of actions is here, and instead of an if, right, so I had my list of actions before, I had an if at the top level. In this case, I have an interval, or an every action with an interval in it, and it's saying every 15 seconds, turn on my Samsung sign, then sleep for 5 seconds, and then turn off my Samsung sign. So I'll save this rule, and then while I'm talking, the rule should start doing stuff in 15 seconds. So let's go back to this. So that's the every action. The other part of that is if you want to do something on a schedule based on like time of day or like sunrise or sunset, then you would use an every action with an actual specific time value. Say at like 8 a.m., do something. And that's the same thing, you'd use an every action for that. So generally, schedule-based stuff is going to be using every action. A location action, right now we only support setting the location mode. So in SmartThings, we have a concept of a locations mode saying home, away, or night mode. A user can set that on their phone or create an automation to modify it. So say that when my presence device reports that I'm no longer within my home geofence, send a location action to my location to make my location mode away. Conditions, yeah, we went through all of them, and operands are how you reference things in the rule API. So let me show you this guy. So this simple if, this right here, what's in this right field for this equals, right? Equals left, right? So this is right. This right here is an operand, and it's a device operand. And the device operand defines what devices we want to reference and at what capability and attribute we want to reference. Same thing for location operands, and then we also have like literal operands such as string and integer for the actual comparison piece of it. So in this case, we're saying reference this device using the device operand and compare that to the string operand open, because the contact sensor state will always be open or closed. So when the contact sensor is open, this evaluation will actually result in a Boolean value, and that's going to be true. And when the contact sensor is closed, the actual value is going to be closed, and the evaluation will result in a Boolean value of false. So yeah, we went through these more examples. I guess let's go back. So yeah, if then else, right? We have an if then else. There's nothing inside of these, but if takes a condition and then a list of actions for the then and the else. So if evaluates to true or false, we'll execute either then or else. And then over there, we have the every action. We have an interval of every 15 minutes. So that's what I'm kind of doing right here. There's a 15-second interval. And in this case, it's just doing a 15-minute interval. And you have different units, seconds, minutes, or days, and then do something on that interval. Here we have the equals condition. It has a left and right field that takes operands. We just talked about that. In this case, you actually see a different type of operand that's not a device or a string literal. It's a location mode operand. Oh, I got this, sweet. So this will then call our API, the location mode API, to see what the location's mode is. And then if the rule that we wrote matches what the mode's ID, then it will execute either then or the else. So this right here is actually a location operand, referencing the location's state. Yeah, we talked about nested rules. We can go if equals, then we can go even more if equals, so you can imagine how complex of rules that you can get. And then in here, we have a greater than, instead of like an equals condition, we have a greater than condition. So instead of checking equality amongst these two operands, what we're doing is we're checking to see if these two devices, device ID 1 and 2, if their switch level attribute is greater than 50. And so the question you might have is like, when will this get evaluated? So every time we have an event in the SmartThings platform, there's a capability and an attribute associated with it. So anytime this device dimmer or this dimmer fires an event for the switch level attribute, we'll evaluate this rule to see if it is above 50. All right, and then commands. We saw some commands, but like we can look into exactly what's in there. The devices is the list of devices you want to send a command to, and the list of commands that you're sending in this command action is defined right here. And like I said before, this is a typo. This should be on. We have the component, the capability, and then the command. And the bad Vlad, you should not have done that. So this is, and here, right here, we have a more complex command. So on command, an on command has no arguments. You either turn on or off a light. But what like we're doing with this device is we're actually making it change color. So the color control capability has a command set color, which defines a set of arguments. And in SmartThings, we define that as something called a color map. There's a lot of drama around like how we did that, but yeah, it's called a color map, and this is how you change color in the SmartThings API. So you just give it the saturation, hue. Hue is out of 100 instead of 360, so if you basically divide by 3.6, and then the level for that command. So if you want to like change the color of something in a rule, like so this Samsung blue rule, right? Samsung to blue, I don't have any conditions in it. I just have a set of commands, and I'm saying change this SCC Samsung sign, use the color control capability with the set color command, and here's that's what you need to do to make something blue. Blah blah. So I'll get so I created that rule, and then I'll just type behaviors execute, and then the ID. That's not blue, is it? Well, it changed its color, but that's all I wanted to show. Maybe I'm colorblind, you don't know. So, and then sending, the location action, right? So here we're sending a location mode action, and we're changing the mode to home. And this is all in our documentation. There's like a lot to remember here. You probably, like, it'll take some time to get used to it. But the nice thing is, since it's all documented in YAML, you can create client libraries based off of it, and then you just use like Java and create a location action object and build this out as part of your app. And it's pretty easy to actually integrate with. And that's what we did with WebCore, right? We have a JavaScript interface to our rule API, and it's as the user is going through selecting what rule they're changing or creating, it's actually building up this rule JSON, and then it just does a post to our API, and the rule starts running. And scheduling. So every 15 minutes, do something, and then at midnight. So this is the other part of scheduling that we didn't look at. So this is a reference point. So at midnight, you can provide an offset. So if you want to do like 8 a.m., you'd provide offset with the correct number of minutes for 8 a.m. So this rule will run this specific rule will run at midnight every day. And yeah, demo, we've been doing a demo the entire time. The rule API, so like what's next? So the rule API is available to use today. Be on the lookout for additional functionality. We'll be adding more actions. We need to get security mode actions added. We need to get other actions added and a whole bunch of conditions. We also want to add things like variables within the rule. Another big thing that we want is being able to share rules. We've seen from WebCore, users really like to build up complex automations and then share that complex automation with other users. And then you just substitute your device ID instead of the original user's device ID for it. So that's also on the hit list. There's a lot of fun stuff that we're going to be working on. And then like my most important thing that I'm trying to get through every product organization within Samsung to let us work on it is local execution, because then we have super fast rules and we don't have to pay for it because it's like on our hub and other wash devices. Check out Developer Workspace. Go back. Check out Developer Workspace. That's where our docs are. Stay for the web core session, because this is basically an intro to the rules API, and the web core session is like what can you actually build on it, and that's what we built. And then check the code lab, go to our community Slack, and then talk to me between 9 a.m. and 5 p.m. on our Slack. That's it. Any questions? Could you come to the mic to ask questions? They asked me to ask you that.
So what is the level of nesting that can be done? Is there any depth to it?
Yeah, so we need to add more validation to that. Right now there's no limit, but we released this today, so we'll be adding a limit probably like in a couple of days. I'd say I think between 10 and 50 is what the limit's going to be.
Okay. And by default, all the rules are local execution, or is there some sort of a flag?
Yeah, so right now everything's executing in the cloud. We need to push out a firmware update on the hub and make some more changes on the hub before it actually executes locally. But that's definitely like the next thing that we're going to be looking at within our team.
Okay, and let's say we have a rule set to turn on, turn off like lots of devices, but one of the devices is cloud connected device.
Yeah.
So how will the local execution play a role in that?
So we have a lot of architecture discussions on how we want to handle that. So in our current platform, it's basically every device that you select has to be local for it to execute locally. But what we've been thinking about doing is if every device has a condition, every device in the condition list is local, then we execute locally at first and send device commands up to the cloud. So we're still in like discussions on how we actually want to handle that. So I don't know yet. My team will figure it out.
Sure. Thank you.
I have a question about the local execution part. So, could you explain a little bit more about how the JSON DSL is related to the local execution?
Yeah, so the way that we actually do that right now is we check to see what devices execute local or in the cloud, and if they're all local, we take that JSON snippet that the user passed into us, and we pass it through, we have a few microservices, and there's basically a pipeline to get down to the hub. So there's a microservice that handles our API. We pass it to another microservice, and that microservice maintains a connection with the hub, and that pushes it down to the hub. And then the hub has its own like subscription and device command APIs that then we can tap into. And our execution engine is the same one that's in the cloud. It's a Rust library. It's running in both, in the cloud and the hub.
So I thought that you mean the local execution. But when you say the local execution, it's like running the JSON DSL on the device without the hub. But
yeah, no, it's a hub. So yeah, we need our hub APIs. It's not just our execution engine running on any random device. You need something on the LAN to be able to evaluate the rules. But if you manufacture a device that is strong enough, talk to our wash team, and we can talk about getting our hub technology onto your device. We have a program for that. So yeah, if your device can do it, then let's do it.
Right, thank you.
Yep.
Yeah, hi. Is there any work being done to extend this to work with devices that are connected through third-party clouds, like connected to an Alexa or something, or also third-party rule engines like IfThen, or is this all thought to always be devices that are connected behind the Samsung hub only?
If you're interested in that, we should talk about it. I'm super open to like suggestions and feedback. IfThen would be a sweet integration. Alexa too, I don't know the Alexa API, but maybe. These nanoleafs are cloud connected, so we have like an SD schema. We talk through that. But yeah, I don't know. I wouldn't want to break any abstractions, right? Like with devices, I want to talk to our device API. And if you want another device, you should integrate with our device API, and then we'll just support you. Cool. So, but like an IfThen, yeah, that'd be sweet.
Okay, cool.
Yep.
Yeah, thanks.
And yeah, okay.
I have a question about the expressiveness of the language. So it seems that you have a JavaScript a JSON description of of a syntax tree that describes events that can happen, if statements, and things you can do. Is there any other storage, variable storage? I mean, it seems like a fairly limited programming model. Is that on purpose, or do you plan, or is the language actually larger and richer than what I'm saying?
Yes, it's on purpose because I wanted to release it by SDC. So the variables, yes, we really want variables, and that's a part of WebCore that we don't support yet. So you're thinking of things like send a message to my phone, but the message should have my wife's name in it, so we evaluate that at runtime. Is that what you're thinking?
I was thinking more like variables that affect control flow, counters, arrays.
Yes.
Basically can I make this at least as powerful to find state automata, or can I do real programming with it as opposed to just very limited response to events?
Yeah. So the for loops, while loops are all planned for development. They're not done yet. Counters are that's where we're going. So we'll be expanding the language as time goes on. We just have a limited set of functionalities, so we wanted to get it out there for people to provide feedback on. So I'd love to hear any feedback you have after this.
Okay, thank you.
Yeah. All right. Thanks, everyone.